Euclid, a telescope that will explore dark matter and energy in space, was launched into space. The name Euclid comes from Euclid, an ancient Greek mathematician called the father of geometry. Euclid successfully separated from the rocket outside the atmosphere about 2 minutes and 40 seconds after takeoff. Euclid will fly for another 4 weeks to enter the orbit of Lagrange L2, 1.5 million kilometers away from Earth. We will start the test operation for 7 months after that month. The Euclid Space Telescope was launched on July 2 on SpaceX's Falcon 9 rocket. The Euclid Space Telescope, like the James Webb Space Telescope, will carry out missions at L2 points on the Sun and Earth. We're going to learn about the Euclidean Space Telescope, which has started a new journey. Let's talk about what purpose and mission it started with. The Euclidean Space Telescope was developed as part of a space observation project designed and built by ESA and involving 21 countries around the world, involving about €1.4 billion and 2,500 experts over a decade. It is the second space telescope to be deployed by ESA at Lagrange Point L2, following the Gaia Space Telescope launched in 2013. Why do you do missions at L2 point? First, the L2 point is where the force of gravity becomes zero. As long as no other external force is applied, objects can always be in the same position, which has the advantage of minimizing fuel consumption. The equilibrium point that is not affected by gravity like L2 point is called Lagrange point. Gravity and centrifugal force to maintain orbit by the two celestial bodies are offset and are not effectively affected by gravity. There are 5 Lagrange points. Among them, L2 point is located in a direction far from the Sun and 4 times the distance between the Earth and the Moon. It is about 1,500,000 kilometers from Earth. Second, it has the advantage of being able to observe the opposite side of the Sun. When the Euclidean Space Telescope revolves around the Earth, it is difficult to always observe the same celestial body because day and night continue to change. Because of these advantages, the Euclid Space Telescope will carry out its mission at L2 point. Euclid's purpose is to discover dark matter and dark energy using the gravitational lens effect to reveal the secrets of spacetime in space. Accordingly, a huge 3-dimensional space map will be created using large visible light observation equipment that can image 30% of the entire universe. Inside the Space Telescope, there are 3 large curved mirrors and 3 flat mirrors each, which have a high quality and wide viewing angle. The Euclidean Space Telescope is planned to operate for 6 years. The Hubble Space Telescope, which has been on a mission for more than 30 years, was located close to Earth, so if it broke down, it would go and repair it. It can be repaired continuously, but the repair is currently suspended due to the high cost. On the other hand, the James Webb Space Telescope or the Euclidean Space Telescope cannot be repaired because it is located at a long distance. The Moon is the furthest place that mankind has gone to so far. The L2 point is 4 times the distance from Earth to the Moon, making it difficult to move, which will result in cost problems. Therefore, the Euclidean Space Telescope is expected to be difficult to use after the mission period ends. Structurally, it can be divided into service modules and payload modules. Service modules refer to infrastructure such as communications and electrical installations that enable the telescope to move. The payload module refers to equipment that enters a telescope and is used for observation. Let's compare some of the features of the Euclidean Space Telescope to the James Webb Space Telescope. The Euclid Space Telescope has a diameter of 1.2 meters, about 5 times smaller than the James Webb Space Telescope. Unlike the James Webb Space Telescope, which can be zoomed in, the Euclidean Space Telescope is capable of wide-angle photography. You can take about 0.7 degrees horizontally and vertically. Given that the diameter of the Moon in the sky is 0.5 degrees, you can see that it can be photographed wider than the size of the Moon at once. The James Webb Space Telescope closely observes distant objects, and the Euclidean Space Telescope has different purposes of observing objects in a wider range. The James Webb Space Telescope makes infrared observations, while the Euclidean Space Telescope can simultaneously observe visible and infrared light. The Euclidean Space Telescope is characterized by its ability to take advantage of both infrared and visible light observation. The advantage of infrared observation is that it can be observed through various interstellar materials and can be observed over long distances. Light that comes far from space gradually turns into light with long wavelengths because of the redshift phenomenon. This means that even if light from afar originated in the visible light area, it would be observed by infrared rays. Using infrared observations, you can see that you can see even further. On the other hand, visible light has the advantage of being able to observe in the same way as we see it, and more detailed observation is possible in visible light with shorter wavelengths. These Euclidean space telescopes can simultaneously observe infrared and visible light to accurately observe distant objects. The biggest purpose of the Euclidean Space Telescope is to create a 3D map of the universe. The space pictures we're looking at now are projected onto a projection plane, all in 2D. We want to create a 3D map that includes distance information on these space maps. If you learn the distance information of distant galaxies, you can 3D what you see as a plane. Through these 3D maps, we will investigate the distribution of dark matter and learn the history of cosmic expansion through dark energy. In addition, we can investigate the characteristics of dark energy and find out what it suggests. The ultimate goal of the Euclidean Space Telescope is to investigate the evolution of the cosmic giant structure. It also aims to identify the properties of dark matter and dark energy through precise observations. So how and by what observations can we identify dark matter and dark energy? In the case of dark matter, we will observe the appearance of galaxies more precisely through the gravitational lens effect and observe the distribution of dark matter. The strong gravitational lens effect takes the shape of an arc in which the galaxy appears to stretch long, and the weak gravitational lens effect takes the shape of the galaxy weakly distorted or bent. We can observe these lens effects with great precision and figure out how curved the galaxy really is, how much dark matter there is, and so on. Unfortunately, Euclid does not see the universe in all directions. There are two of the most embarrassing distractions when mapping the entire universe. One is the disk of our galaxy itself. Because we have to map the universe trapped inside our galaxy, we cannot see beyond the Milky Way, which is densely packed with stars and dust. Another hindrance is our solar system dust. The interplanetary dust that spreads along the orbital surfaces of solar system planets also blocks the view. These dusts are the remains of planets in the solar system a long time ago. In fact, where the sky is really clear, you can see faintly the appearance of the interplanetary dust band reflecting the sun's light. Euclid avoids these two distractions, the Milky Way disk and the solar system dust disk, and maps the entire universe only in the remaining directions. As such, the survey observation, which completes the 3D distribution map of galaxies in space, has already been conducted through the famous Sloan Digital Sky Survey. However, Euclid completes a more detailed and huge map of the sky than even SDSS can compare. SDSS is a survey observation that looks through the sky with a 2.5-meter ground telescope located in New Mexico. Therefore, it is possible to draw only a map of the sky, mainly seen from the northern hemisphere. In addition, since it is ground observation, there are naturally many limitations compared to space telescope observation. However, Euclid goes out of the Earth, orbits in space, and draws a map of the entire universe, regardless of the northern and southern hemispheres. Euclid is responsible for observing and studying dark matter and dark energy that make up most of the universe. It is estimated that more than 70% of the materials that make up the universe are made up of dark energy. Therefore, based on Euclid's observations, we want to examine the structure of the universe and the expansion process. By measuring distances through supernova observations, and by measuring speeds through redshift, we can compare the early and present appearances of the universe. This allows us to see changes in the rate of expansion in the universe. Euclid is made of a combination of large panel-shaped equipment and telescopes that block the sun's hot light to observe while maintaining temperature. The telescope uses the gravitational lens effect to observe dark matter. The gravitational lens effect is a phenomenon in which light from other celestial bodies bends due to the strong gravity of a mass material. Since dark matter also has mass, the plan is to use this principle to find out the reality of dark matter by capturing the phenomenon of refraction when passing through where dark matter is. The Euclidean Space Telescope was built by the European Space Agency. NASA is currently preparing the Nancy Grace Roman Space Telescope for similar observations. But please don't underestimate such Euclid. Although it doesn't break the distantest record, instead, Euclid will map the biggest ever